Welcome everybody. This is not a normal general meeting for the FACC, so it's just us and Dr. Lee. I'm not going to introduce Dr. Lee since we've done that in the past two videos, but what I am going to do is I'm going to mention a few things that I've read in Facebook and on the YouTube channel. A couple of things about the videos. Valerie Zimmerman says, inspiring video. Shared it with the ISOG group just then, and we'll pass it along to a few other groups as well. Earl Chambers says, the best Y-DNA video I have watched since viewing Dr. Maurice Gleason Y-DNA videos. Can't wait to watch part 3. Peter Langley says, fascinating. It has made a lot of things clearer to me and easier for me to explain to my group members what it's all about. Number 1, SNPs are accumulations of mutations over time. Number 2, each mutation represents a name of a person who had that mutation. Of course, they're going back, those names are lost in the midst of time. Number 3, it is not known what chronological order a block of SNPs come in. It is only when people test and only have some of those SNPs that it becomes clear. I think he explains it fairly well. And the last one is, please bring Dr. Martinez back for 1 or 2 more segments. So invaluable. And I thoroughly agree. So with that, Dr. Martinez, I'll turn it over to you.
Thank you. Go ahead and share my screen. Let me know if you see my PowerPoint.
Yes,
all right,
sir.
Awesome. So we talked about, I introduced a block tree last time, and I introduced the concept of blocks of equivalence last time. So we're going to now after all this time we've been building our knowledge, I'm going to take us home with how we use all that to strategically recruit folks to help manifest the tree. And I like to use the word manifest because we're not really building the tree, right? The tree's already there. We just don't see it. So we're uncovering something that's hidden to us. So a pretty, just very focused agenda. I just want to go over the rule of 4, and if I have time, what's next for Y-DNA, but this is just fluffy stuff here. So this is my main focus. So I want to start by introducing what I call the rule of 4. It's a modified version of the rule of 3. The rule of 3 is probably what it's more known for, a testing strategy developed by Bill E. Wood. So this is really everything I'm showing you today. Bill has been espousing for years, and this is kind of my take on it, and how I leverage it for kind of my situation, my reality. So so Bill does start off by explaining that the haplotree has historically been built from the top down, focusing on ancient branches, and we talked about that pretty in depth last time, right? So if you take the test for the first time, you take a lower level test like the Y11, Y111 or the Y67 or Y37, or you take a big Y test, but you're not part of a group or a strategic group of folks taking it, you're gonna probably end up starting with a haplogroup like this. And so this is what it looks like at the top of my block tree, right? It just keeps going. There's these breadcrumbs, and you can just go back, and yeah, if you click this ellipse symbol, it'll keep going all the way back to Y-DNA atom. So when Bill talks about top down, this is what he's talking about. You're coming from, QM3 downwards. And this isn't, we are genealogists. So while this is great for genetics, Bill's point is that from genealogy, you want to start from the bottom up. So this is that same block tree, but this right here is me, right? Which I've talked about before. And then this is like the next 3 generations up above me. Same thing with this person right here. This is a person walking around right now somewhere in this world, and they're underneath so this represents them and them alone. And then they're underneath this giant block of equivalence, right? Now we know what a block of equivalence is. So Used this way, the Big Y test can discover previously unknown SNPs. These are these private variants, right, that you see in this turquoise color here, on the tester's branch on the haplotree within genealogical time, right? So again, these two pieces of information here are within the lifetime. These are people alive now. And this here, like I said, is probably 200 years, right? So this, and I apologize if I'm repeating from previous, but this FT3291 is a mutation, and it's 300 years old. So within all this stuff here is in genealogical time. None of this is in genealogical time. This is more like, saber-toothed tiger time. You're back here. You literally have mastodons and saber-toothed tigers running around. This is not in genealogical time. This is like before the Stone Age. Here we're talking about like decades and centuries, right? Another important concept is that the haplotree evolves constantly as testing reveals new data. So as an example, just last month, this was my block tree. Today, this is my block tree. In the last 4 weeks, it's grown. You guys see that?
You're muted.
There we go.
I think I accidentally hit that.
That's okay. Someone over the last 4 weeks, actually it was like a week after I presented this, within a week, it was now obsolete. And the interesting thing to know is that family tree DNA doesn't tell you. It'll tell you of a new tester that's never tested before. You'll get an email saying you have a new match, right? But if that new match upgrades, let's say that new match goes from a Y67 to a big Y, it won't tell you that happened. It won't tell you that your tree changed. So you have to go back and look at your trees. But I was preparing for my PowerPoint, and I'm like, oh, snap! Someone's results have come in. Do you guys see where it is?
Yeah.
There's a new branch, right, that didn't exist before. And so, bottom line is, it's constantly revealing, constantly growing. And so, like I said, on a monthly basis, I'm constantly getting new branches being built on as people out here are testing. Okay. All right. Only a test like the Big Y can reveal your personal recent history Y DNA SNPs. These are your private variants, right? So these are private variants here. Average 2. These are private variants, right? All here. So only a test like the Big Y can reveal these personal private variants. These are variants that have never been discovered before. They've never been known to science, and they're private or unique to you or the group of you. So, for example, here it says average. So it's not just here it says average 1. Whenever you see average 1, it's usually it really isn't a true average. An average, you need multiple people, and then you divide by that number of people. That's your average. This isn't an average. This is one person, and this isn't an average here. This is one person. But this here is actually 3 people, and this could be multiple people. And so you could have, this could be 20 private variants, but amongst, if you have 2 people and each has 10 private variants, you have an average of, you could have an average of 9, if that makes sense. So you have these private variants, but these are brand new, and only the Big Y test can bring these to light. These other SNPs up here are known to science. They're in a database, right? They're known, they're cataloged, they're a location on the chromosome, like your house in the city that you're at has an address. It has an address, it has a name, it's known. These private variants, until that person took that test, no database knew this data. Nobody knew, right? And this is why the Big Y is so amazing, is it's a test of discovery. The other DNA, all other DNA tests, whether it's a autosomal DNA test or a lower level Y DNA test, they're not tests of discovery. They're tests It's like you go into a library and looking up a book, right? The big Y is you going in and you wrote the book, and you're giving the library a book that never has been belonged to that library before. Because this test is expensive and multiple tests are usually required, and this multiple tests is what the Rule 4 is all about, to get the best results, a testing methodology is warranted. And so that's where kind of Bill Wood comes in with his kind of, hey, I have a testing methodology that is efficient. It's a technique that strategically selects patrilineal relatives with the express purpose of getting all private variants named. So that's a very important concept, right? Resulting in a terminal SNP and oftentimes a family clade. So there's a couple of concepts here, right? I just explained what a private variant is. It's a mutation that is unknown to science, that is only known because you just took a test. And as far as we know, you're the only one that has that is private to you. A terminal SNP is a haplogroup that is the most recent that is known to science. So my terminal SNP has changed over time. When I first entered this, QL663 was my terminal SNP. See what I mean? Then QFT5172 became my terminal SNP. Now these other were manifested after this, but they are not my terminal SNP. A terminal doesn't mean last. It could mean last. I mean, technically, for my dad, QFT5172 is not just his terminal SNP, but it's his terminal SNP, meaning there's no amount of testing is going to get him a new, farther down the branch. That's as far down the branch as he's ever going to get. So it's a true terminal SNP. But for this person, he has this terminal SNP, and it's possible someone could come along and take a test and he could get a terminal SNP that's even more recent. So a terminal SNP is the most recent, is the farthest down branch that you have at the moment. But it isn't terminal in the case that it's the end necessarily. For most people, unless you have a haplogroup that's within 100 years or 200 years, you still have your terminal SNP can change and move, right? Again, strategically selects relatives to get the private variants named, resulting in a terminal SNP and oftentimes a family clade. Again, a family clade is a haplogroup that is unique to a family, right? So QFT5172, only my dad, my brothers, my first, second, and third cousins, uncle, granduncles, we're the only ones that will ever have that haplogroup because it's unique to a family. There's another family out there that connects to us maybe 300 years ago, but they're different. They're upstream from us. So family clade, that's a concept. All right. So these first 6 are the objectives that Bill would put out for his rule of 3. Establish a paternal SNP profile, and I'll show you what that means. I'll just show you now. So a SNP profile means that you have a path from you all the way back to the beginning of time. See what I'm saying? So all these folks down here, it's when you get down to wherever this is, right? As I hover along the bottom, think about an anchor. It anchors your genetic line from you back all the way to the beginning of time. So that's one thing, one objective of this process. Creating a family SNP timeline, which you've already seen me present multiple times. I'm able to show you dates and even names on my SNP timeline within the family clade, which is number 3 here. Determining a time to most recent common ancestor. So I've demonstrated that as well, right? I've been able to say, hey, FT3291, this mutation here is Nicolas Espinosa, who was born in Jalisco, Mexico in 1673. So that's that objective, right? Identifying time to most recent ancestor of all of these folks. I know the name of this person, who's the most recent common ancestor of my family clade, and this other family clade, and then I have my third great grandfather here, who's the most recent. So I actually have 1, 2, 3 times the most recent common ancestor, depending on what group I'm talking about, right? Objectives here. Identifying early branching points within a family group. So again, these are this is a branching point. 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 When I think about the law of evolution, when I think about evolution, and I think about what's from an evolutionary point of view, what makes you successful, and it isn't money and it isn't property. It's passing your genes along. So when I look at this person right here, FT32098, whoever that was, in my mind, I judge that person very successful. This person had passed 1, 2, 3. They passed their Y DNA profile down to 3 separate lines. It could have been 3 sons. It could have been a son, a grandson, and a great-grandson along different lines, because the mutations don't happen every generation, right? It happens like every 3rd generation. This person likewise, whoever this person was, from a evolutionary point of view, very successful, passing along their genes. All right, connecting branches where no paper trail exists. Again, the earliest paper trail I have is right here, and so from this point backwards, everything I learn is pre-paper. So these are all objectives. And then I added a 7th objective, which is why I changed it from rule of 3 to rule of 4, which is to continually break up those blocks of equivalence. Again, at least because I'm on Q, Native American line, we tend to sit underneath a large block. See that? So while this person has, this is them, look at that. That's thousands of years, right? 2,000 years worth of a block of stuff. We want to break those down. And even though because of the rule of 3, which is exhibited in here, and I'll show you that in a minute, even though I've exercised the rule of 3, I still want to break these up because I need to learn more. And so I'm not done. I still, and there's a technique to do that, which is why my tree keeps breaking up. This isn't by accident. The people who are taking these tests are taking them because I'm recruiting them. I'm emailing them and saying, hey, take a test. I want you to take the test because I want you to break up these blocks. All right. All right, so before I walk through the different steps, I'm going to do a real quick version. Let me just get rid of that. Move this over. Make it bigger so we can see it. So I'm going to just run you through the rule of 4 really fast, and then we're going to take it again, but really slow. So the first is you taking the test yourself, right? So this is a good example right here. Here's a person, they take the test, and they create this anchor, right? This genetic profile from them, anchored here to them, all the way back up, all the way to Y-DNA atom, connecting all this known knowledge with the private variants, right? Then, very similar, then the second step is to find a close relative. Why? Well, it's really kind of based on some simple statistics. So let me do a really quick introduction to statistics. Very simple. Flipping a coin, right? What is the probability that it's going to be heads? 50%, right? And so, but what happens if I flip it 4 times? Is it possible, even though the probability is 50%, for me to flip 4 heads in a row? Yeah, it happens all the time. Just because I flip 4 heads in a row doesn't mean I've disproved that the probability is 50%. And just because I flipped 4 heads in a row doesn't mean that the next time I flip, it's more likely to be tails. It's just as likely to be heads as it was the first time I flipped it. So I say that because basic statistics say that the greater the sample size, or for in our case, perhaps the farther back in time, the more likely statistics are going to be accurate. So when I say that on average, a mutation, a Snip mutation occurs every 83 years, as an example. It doesn't mean that you take the test and it's going to be every 83 years. It just means that as you go back in time, it's going to be more likely to be 83 years. So back to the flipping of the coin. If we were to bet money, $100, let's say there's $100 on the table, and we're going to bet that if I flip the coin, it's going to be 50% of the time heads, 50% of the time tails. Well, if I flip 10 times, it's probably not going to be 50-50. But I flip 100 times, it could be 49-51. And I guarantee you that if I flip 1,000 times, it's going to be bam, right on 50-50, right? That's why in science, we when we want to do an experiment, we want to get as many people as possible or as much data as possible. The more data, the more people, the more time, that bell curve tightens. In the case of flipping a coin, it will tighten around 50-50. So the same thing, when I say 83 years, the farther back in time I go, the more true that's going to be. So when we're talking about you, and we're talking about just a couple hundred years, well, here's a good example. What this tells me, if I know that this is 300, this basically says that it's been about 300 years at least, and there hasn't been a Snip mutation on this line. See what I mean? So there's an example where it's an outlier. It's not, it doesn't match the average. But for purposes of coming up with a strategy, we use 83 years. In Q, I use 81.5, but 83 is fine. To kind of figure out how often these Snip mutations occur. Well, what does it have to do with the second tester? Well, the goal of the second test is to name all those private variants. They're private at this point in time because you're the only one that has them. No one else in the world shares these variants, right? But what's the chances that you have this many mutations that only belong to you and not your brother or your dad? The probability is very low. The chances that your father or your son or your first cousin also has the same variants, they just haven't been discovered yet because they haven't taken the test, really high. So, and I'll show you some examples. So here, this line right here is in these actually, both of these lines right here have taken that second step. Step 1, you take the test and you anchor. Step 2, name the private variants. Well, I can tell you that this is two brothers. And this is like a father and a son, or two brothers as well. So the difference between these two and this one is that these two had a close relative take the test, a brother, and sure enough, 100% of those so-called private variants ended up not being private anymore. Why? The brother had the exact same mutations as would be expected. Does that make sense? Let me just stop here for a minute. Is everyone understanding what I'm saying so far? It doesn't always happen that way, though. There's a probability, statistics, that maybe there's a small number of private variants that are unique. Here's an example. I have a private variant my dad does not have. My brothers don't have. My uncle don't have. My cousins don't have. It's me. Well, the law of probability said that every 83 years, you're going to have something that's a new mutation. I just happen to be that person, right? It's just luck that it was me. Here's another example. In this instance, this is two brothers. This is what happened from last month. This wasn't like this, if you remember. Last month, it looked like this. I'm sorry, where is it? 663. Yeah. Last month, these two were in this one bucket. All of this, one bucket. This had 3 people in it. No, 2 people. This had 2 people, a Carranza and a Pata. The Carranza got his brother Carranza to take the test, and now the Carranza brothers have a branch. They branched off from Pata, and now they have their own branch. And one of the brothers had a mutation that the other brother did not have, one. Is it possible you have more than one if you have a brother or a father or a first cousin? Well, yeah, it's possible. Just like it's possible to flip 7 heads in a row, but it's unlikely, right? Highly unlikely. Here we have 2 private variants amongst 3 people over 300 and some odd years, right? So you can see here's another example where it's not really 83 years. It's more like, it's a bit longer than that. But the bottom line is this. There's enough knowledge of the average rate of a SNP mutation to say, rule number 2, get a close relative, name those private variants, which is exactly what happened between here and here, right? Name those variants. Number 3, you then want a family clade. So this person, right? This person here had his brother take the test. They now have a terminal SNP that's unique to them, but it's 2,000 years old. I mean, right? So what would I tell this person to do? What's the 3rd step? The 3rd step is recruit a 4th cousin. Why would you recruit a 4th cousin? Well, if the mutation happens every 83 years on average, right? Every 3rd generation or so, a 4th cousin is far back enough where you're going to split this Y14889 or maybe even this FTA 4756, right? These 1 or 2. It's far back enough where you can split. If that 4th cousin takes the test, you now have a family clade. You've split. And instead of having a 2,000-year block of equivalence, you have 1, like what happened to me, or maybe 2, what happened to him, block. And now you have a terminal SNP that's within genealogical time, and that was the 3rd step. Step 4, which is why I call it the rule of 4, is that, well, that's great, but I would like to then further start chipping my way up this block. So in a really quick way, that's the rule of 4. So let's go to step 1. So now we'll slow it down. Step 1 involves establishing a paternal genetic profile. Again, it's that anchor from you all the way back to that first Y-DNA atom. So this is who is this candidate? Well, it's usually yourself. Or if you're a woman, it could be your brother or your father, right? Or in my case, when I wanted and I'll show you this here in a minute, I don't want just my patrilineal line. How about my maternal grandfather's patrilineal line, right? Ted Archuleta. I want to know Ted Archuleta's line. So I'm going to find a nephew or a brother or a son of Ted Archuleta to take the test. So, right? So it's not just women that need to find a first tester. Yeah, it's yourself if it's your paternal line, but how many paternal lines do you have? You have a ton of them, right? If you have 4 grandparents, everyone has 4 grandparents, you're going to have 4 paternal lines. You're going to have your grandfather, your maternal grandmother's father, right? Your paternal mother's father. I mean, right? And so half of all your lines as you go back is a Y-DNA line, right? So it's not just it's not just one line going back in time. You have more Y-DNA lines going back than you can throw a stick at. There are a lot of them. Does that make sense? So that first step is to find that candidate, whether it's your line or someone else's line along your tree that you want to do a Y analysis on. So when I started out, so this is an example of my grandmother, my dad's mom is a Sanchez, so we thought. And so this is the big Y-DNA test for my paternal grandmother's father's line. And if you look, her last name, her maiden name was Sanchez. But I see here, these are my Y-DNA Y111, Y37 test results. Salazar, Alvarez, Mestas, right? Lopez, Mayas, Archuleta. You're like, yeah, a bunch of Sanchez's. Yeah, but those bunch of Sanchez's are only there because I recruited them. If I hadn't gotten my finger involved in this, there would probably be no Sanchez's in here on my Sanchez line, right? Now, through the New Mexico Genealogical Society, we have several. You can notice the little symbol there. We have the genealogy for these folks, and all of these folks seem to coalesce around a Lopez. So I think that this surname is a Lopez, and then who knows what the surname was before this Lopez in New Mexico. So in this case, the first candidate here was my first cousin once removed. We'll call him Mr. Sanchez. Well, yeah, it's a Sanchez line, right? So my grandmother Sanchez can't take the test. Well, she's passed away, and she's a woman. So I then reach out to her nephews and say, hey, who wants to take a test? And so here's the first test, right? He takes the test, and he creates his genetic profile all the way back, up, and then across. And then again, you can just keep navigating all the way up, all the way through Africa, all the way back to the beginning of time. And then, even with that one test, I can see the migration pattern of that Sanchez, Lopez, whatever line through Paleolithic, Mesolithic, Bronze, Iron, onto modern. Now, be careful with Snip Tracker. We've demoed this in the past. Both myself and others have demoed this tool. It's not always accurate. I can call BS on this test right here, this result. There's no way that this is 1700 of the Common Era, right? That this matches, this piece of information is wrong. And usually I can tell the algorithm's breaking when you see this 83 BC, 83 BC, 83 BC, 83 BC. There's no way that you're going back mutation to haplogroup to parent haplogroup to parent haplogroup to parent haplogroup, and the date not change. So if you see that, you can kind of tell that this is probably accurate up to about right here, and then it starts to break. So be careful when you use that tool. You have to look at the data and to see, right? So if I look at this and I eyeball it, I know that let's see, what did I use? Yeah, ending in 708. So if I look at ending in 708 right here, that's, 20 mutation. I'm using this here on the side, 20. Instead of counting every mutation, I can use this tool here. That's about 20, right? Times 83. That's 1,660 years ago, right? So I know that this is only a few hundred years ago. So it's wrong. So just be careful with this tool. So that's what happens when person number one. That's a lot of information. The general branch you're on. For me, I found out I was on QM3 instead of R. That was big, right? Just by taking that one test. You get this migration. Again, for North America, remember that Snip Tracker doesn't work for native lines. So this is only working for the old world. All right, step 2 is that second candidate. And in this case, this is a close relative, a father, brother, uncle, first cousin, son, or nephew to the tester. Why? Because you want to name all those private variants so that you could then. So my advice to the Sanchez family is I can go to, in this case, I have a first cousin of Mr. Sanchez that I also recruited is taking the Y37, I think. So I sent him an email. Dear first cousin once removed. Hey, my other first cousin once removed, your first cousin, has taken the big Y. And I really would like you to take the big Y. I can't afford to help you, but hey, it's Father's Day next month, and it's going to go on sale, and would you take the test? So I'm recruiting him. What would happen if he took the test? All or all but one of these private variants will get named. Okay, I know this, right? I can predict what will happen to the tree based on somebody taking the test. Now, I just want to go back a little bit and say that it isn't about the number of people. It's following these 4 steps, because in this instance here, where I have a private variance of 2, people keep taking the test along this line and it doesn't do anything, right? I have a Cruz, I have a Romero, I have an Espinosa. The problem is that they're not closely related. They're all like ninth cousins to each other. They all descend from this one, right, common frame along this line, but they're so far apart from each other in time that they can't seem to manage to get these private variants. And therefore, instead of having a 200-year-old haplogroup, they have a 2,000-year-old haplogroup. And the difference between this 200-year-old haplogroup and this 2,000-year haplogroup is a single test for all 3 of them. I've said this before. If all 3 of them had a brother take the test, you'd have 1, 2, 3 new branches. All of those branches would be within genealogical time. Instead of having 3 branches within genealogical time, you have 1 branch that's way back and they can't use. So it's not about the number of tests, it's the following these steps. Okay. So as you're taking and recruiting folks to start manifesting your tree, it's important to know that how to interpret your test results. So I mentioned it earlier today before the actual meeting started. Someone said, "Oh, I took the test and I'm waiting for my results." And my response was, well, be patient because it can take many months to 3 months of time, assuming that the test goes through the first time, which most of the time it does, but sometimes you have to retest. And so you have people 7, 8 months having to wait because they didn't pass quality control. So just if they could just speed up this test, that would be the biggest thing, but it takes a long time. But even after the test is marked complete, you've taken the test, you recruited your brother or your uncle or whatever, and they tell you, "Hey, my test results came in today. I got an email saying your test results are done. Let's call Lee and have him help us with the results." My response is, give me a call in 3 weeks. Every time. It's like, call me in 3 weeks. Because even though the chemistry part of the testing is done, the block tree piece isn't. It's called manual review. There's still a human being at Family Tree DNA needs to go and move things around. So again, when this person took the test, had his brother take the test, and they got an email saying, your test results are done. If I had gone in on that day, or even a week later, or maybe even 2 weeks later, it would have looked the same. It wasn't until 3 weeks later that it would look like this. See what I mean? So this piece, changing from this to this, takes about 3 weeks, sometimes 2 weeks. I don't know. It takes a few weeks after you get the final results. So just be aware of that. And it's painful because just the waiting, it kills me. All right. Yeah. So I covered all that here. All right. The third step. This is where you want to recruit that 4th cousin. Now, it's not that simple because not everyone knows. This isn't just a 4th cousin. It has to be a specific type of 4th cousin. It has to be a patrilineal 4th cousin. And it's not that easy to find. It's not everyone said, "Oh, let me just grab from my Rolodex my list of patrilineal 4th cousins." I have a pretty good genealogy. I don't know any 4th cousins that I can identify to recruit. So what I did is, if you can't find a 4th cousin, then you can maybe get a 3rd cousin, right? Or a great uncle. Or if you don't have either one of those alive, you can start looking at your STIR matches and find someone that's, you don't know who they are, but their genetic distance is pretty close to you. So these are all different ways of going about it. I actually went for the 5th cousin route. I wanted to go farther back. I actually had several 3rd cousins that had taken the test, but I decided to go, kind of looked at it this way. I could do the 3rd cousin, and if I went the 3rd cousin route, Juan Antonio Martin is our common ancestor, right? That I have with these 3rd cousins that are out there. But I did have this 3rd cousin 3 times removed, right? This guy here. So rule of 3, rule 1 was myself. Step 2, my dad. Step 3, a 4th cousin, I recruited this person right here. Here's my most common ancestor to him. So siblings, first cousins, second cousins, third cousins, once, twice, 3 times removed, right? So, but this is like, you know, similar to getting a fourth or getting a fifth or sixth cousin, but that's who I recruited. And the result was QFT333300. This branch broke off from QL663, boom, right here, and is a branching point, right? This Lobato line, which is really a Martin line, which is really a Espinosa line, which is really a Gomez line, which is really not that either. It's a native line. So if I've learned anything is to forget about surnames because they change. What doesn't change is the Y-DNA path. So yeah, so this was the branching point here. And then this is the Espinosa. So this is the Martin line split from the Espinosa line, and this is the Espinosa family of New Mexico, right? And then this is the Lobato and Martin, Lobato split from the Martin line, and so you have the Lobato line and the Martin line. So this is right. You're finding these branching points going back, so forth. Then I have, remember, Bill Wood calls it the rule of 3. I call it the rule of 4. Then for me, it's breaking those block of equivalents. I'm not done, right? After getting this and this and this, all from using 3 rules, I actually got this by following the 4th step. See what I mean? If I hadn't done that 4th step, I wouldn't have this. It would look like this. And oh, by the way, it's really not. It's the rule of 4n, or because I'm never going to stop. I'm going to keep working my way back up. But it's the same concept. So let me talk about the rule of 4. And then once you get the rule of 4, then you'll get the rule of 5 or 6 and the rule of infinity, right? As you go back. Let me find my way. Yeah. All right. So how do you find that 4th candidate? So what you do is you want to find somebody that is a match to you, but really far out. And so I recommend picking your Y111 match with the farthest genetic distance from you. Now, there's rules, right? If it's too far out, they're not a match and they fall off the list. So for example, the rule for a Y111 is genetic distance of 10. If you have someone that's a genetic distance of 11, they won't show on your matching list. See what I mean? They're too far. So genetic distance of 10 is as far as you'll go. So what I did is I recruited Mr. Pata, who is this person right here. Mr. Pata right here is a genetic distance of 10 at Y111 to me. See what I'm saying? And so I recruited him to take this test, and I'm hoping he's listening to this video right now. Mr. Pata, get your brother, your uncle, your nephew to take this test so we can name these. All right, now I've done my commercial. I was done. I have to, come on, take the test. So that's that 4th rule, right? Is that you go, that's how you identify that person. If you don't have a Y111 match, who's your farthest Y67 match? Or your farthest Y37, whatever, you know, that farthest person that is still technically a match to you. He's showing up on your matching list, but he's so far back that you don't have a common ancestor, right? Mr. Pata, I keep going back to this, both Mr. Pata and the Carranza brothers here, the thing they have in common that's important to me is that their most recent common ancestor isn't Nicolas de Espinosa. See, these are New Mexican lines right here, right? This is a native Mexican leaving during the País Hurtado expedition of 1695. Yeah. Came to northern New Mexico. So I know the history, right? I have the records. I know who this person is. These 2 people are important to me because their ancestors predate New Mexico history, New Mexico colonial history, right? I want to know as much as I can about these 2 people because I already know all this. This is all written in history books, right? I don't know this. So these 2 people, super important. If I could find somebody who's closer to me than these guys, but I'm sorry, closer to me than these guys, but farther than these guys, so I can start breaking these up. So I don't know who that person is. That person doesn't exist. So I'm just like fishing, right? I'm sitting in the pool, seeing if I can get a bite. I'm constantly waiting for someone in the world, someone in Mexico or the Southwest United States to take this test. And I get that email. I'm waiting for the day where I get the email. You have a match. I look at that match, and they're a genetic distance of 9 at Y111 or 8. And they're not a New Mexico name, and they're closer than these guys, but farther than these guys. Boy, I'm going to be after that person. I'll even risk funding it, and that my wife can't know, because if my wife finds out I'm in the doghouse, that's how desperate I want that data, right? I want that person person's out there somewhere, right? So hopefully you're getting a sense of how there's a specific way to manifest the tree. So all of these branches here exist because I made it so. Does that make sense? I either took the test myself, or I helped fund the test, or I convinced someone else to fund the test, and I sent emails out and said, please take the test. When I started 3 years ago, QL663 was the terminal SNP. And it's not just not affected my line, but there's other lines over here, ancillary, more ancient than QL663, that also came about because I've recruited, because I want to build this out, right? And you can see back in time, yeah, if I go back a couple thousand years, there's somebody who's living in like Ecuador, and you see all the different countries. It's interesting, right, to see where the descendants of these people. Now, QL663, that's like everybody that's native in the Americas is QL663 almost. So it's like, yeah, that's nothing there. But right here, super interesting. It tells me that my line's been in Mexico a really long time. So this is what when I first took the test, this is what it looked like. Look, see the difference between this and this? This is 3 years ago. This was 3 weeks ago. None of these branches are on here. It goes from QL663 to BY66731. That's right here, BY66731. So none of this. It was QL663 and this. None of those branches existed 3 years ago. This is what it looked like. All right, how are we doing on time? Oh, I'm actually going to get through a presentation. All right, so what's coming up? I'm really excited. There's a lot of exciting things coming through the pike. For me specifically, a lot of ancient and academic samples are making it into the into the family tree DNA tree of mankind. So think Kennewick Man, or things like that. You guys see it in the news, right? They find like ancient Viking remains, and I'm like, yes, take the test, take the DNA test. When they find remains like that, those make it into that big tree, right? Age estimates. So you can see how I took out my calculator, right, and I started doing mathematics and trying to figure out how old it was. But I'm hearing that there's going to be more age estimate functionality being built into the haplotree, into the block tree in years to come. Family finder haplogroups, which autosomal matches could share your paternal line. So that's a new kind of tool that is being developed for family tree DNA, which will help you kind of maximize your autosomal matches in a more automated way. Right now, a lot of this stuff can be done, but it has to be done through just knowledge and a lot of work, right? And so family tree DNA appears to try to be handing it, putting it in a format that's more usable for the common person. Putting dates to things is important. We talk about age estimates, right? So if I throw an age estimate on this, it gives you a sense, right? That's me. I know the date of this because I know this person's birth date because of the muster. He during the País Hurtado expedition, he had to sign up and say how old he was. So that's that date. Then using that 81.5 years per SNP mutation, This is about 1200 CE. This is important because I'm thinking what's going on in the American Southwest and Mexico at that time, right? This is the beginning of the Aztecs, right? 100 BCE, so it's important. It helps you kind of see this tree in a different way when you can put dates to it. Here's another kind of way of looking at it, right? My second great grandfather, my fifth great grandfather, Nicholas, blah, blah, blah. Okay, so how can I participate? Why do I even do these, right? This is like, think about the hours of time I spent doing these on my Saturdays. Well, it's the only way. You have to, the more of you that participate, the more value we all get. And as a New Mexican, I'm related to every one of you. Every one of your Y lines is going to be my Y line eventually, somewhere, right? So when you take the Y-DNA tests, you're helping me out because you're going to find something that I'm going to want to know, right? So the Rael family has taken the test and theirs looks really good. The Martin Serrano line starting to really, the Martin Serrano line is getting to the point where you can now identify multiple sons of Bernard Martin Serrano. It's getting really good. And there are people here on this presentation that will be presenting these findings to you guys in future times or maybe writing things up on this. It's ancillary to me, but I'm seeing it saying, cool, tell me about it. I'd like to know. Just tons of names that are making great progress, right? So if you're a male, you can get a big Y test for yourself. It goes on sale next month for the week of Father's Day. Don't forget your mom's father had a Y chromosome, and that can help you with your genealogy. So don't forget mom, her father. If you're a female, ask your brother, right? So in other words, everyone can participate. It goes on sale next month. I mentioned the academic studies. So FTDNA has added almost 5,000 Y chromosomes from present-day males that have participated in academic next generation studies, including the 1,000 Genomes Project, the Human Genome Diversity Project, the Simon's Genome Diversity Project, and many, many other studies. So there's a lot of peer-reviewed science out there that is going on that then adds value to the tree that we can all benefit from as well. And then I talked about age estimates. Really excited about that. So I'm expecting to see added value add to the product that we purchase. And I guess my final word as I end is it is the gift that keeps giving. Yeah, you spend $350 to get a big Y 700 test, but every time someone out there takes the test, you get a gift. It's like a little gift, right? Every time someone out there is taking the test and your tree grows. So like I said, when this happened to me in the last few weeks, how much money did I spend on that? Nothing. Someone else spent the money and I valued, right? So that's the cool thing. Yeah, you make an investment, but then you become part of a bigger thing, and as other people out there invest as well, you then benefit. Okay, so that is my presentation. I actually made it to the end. I don't even know what to do with myself. So I guess I can open up for questions.
Yes, yes, you can. We've got a couple of questions in the chat. If you'd like to type in some questions, you can do it there. Or if you want to just speak it out, you can unmute yourself and do that. But first, let me take the first two questions that are in the chat. Rebecca says, what causes a mutation?
Yeah, it's random. It's so think about, have you ever made have you ever taken a piece of paper and put it in a copy machine and you're making 100 copies, and then you'll take a copy of that and you'll take one of those 100 copies, and then later you'll make another 100 copies. And eventually, if you keep doing that, making a copy of a copy of a copy, you're going to have degradation, right? Something will change. So mutations happen in our bodies all the time. And so it's just a random, you pass your genetics on to your children, right? But every time that the gene remakes itself, makes a copy, it's not perfect. It's little mistakes happen, right? This is the foundation of evolution, right? Mistakes happen, And some of those mistakes are helpful for us. In this case, it doesn't affect us. It's just a marker that changed. It doesn't affect your color of your eyes, your how tall you are, or anything like that. But it's just a mistake. So it's pretty amazing that you can go on average 83 years and have perfect copying going on, and only once every few generations a little teeny mistake happens. It's just, if that makes sense. I know I'm oversimplifying that.
Yeah, thank you. I know for sure. I think that mutations like these are not necessarily bad like we normally think of a mutation. So keep that in mind. The next question is, are you using YFull?
I have YFull. Use it? Not really. But there are people out there that use it. I don't find any whole lot of value. I don't go into YFull and say, oh, there's some information I didn't have.
Can you explain what YFull is?
Yeah. So, for example, I'll make this very simple. So, FTDNA has its database, right? But it's only for FTDNA. FTDNA is not the only place that you can get Y-DNA testing. There's other tests out there. YFull is, think about like a consortium that gathers DNA tests from other places, and then that way you can compare yourself to a larger group. The thing is that, and I think Bill Wood would agree with this, 95% plus of all the Y-DNA tests are being done through FTDNA. So I don't really see the value of adding that 1%. It's not worth my time to go after that extra 1% that might be out there. If I have 98% of the Y-DNA coming from one place, because there's a monopoly, so to speak, of Y-DNA, then I'm coming here. If there were other Y-DNA companies providing similar Y-DNA, and I didn't have visibility of those matches, then YFull would be really important to me. But because that's not the case at this point in time, I personally don't. Now, am I on there? Yeah. And have I looked at it? Yeah, but I haven't really gotten any value out of it, nor do I expect to, for me personally.
Okay. Another question from Jeanette. I have a half brother, Martinez. We have the same father. If he tests, should another brother test, or the first brother's son, or someone else?
Doesn't matter. As long as it's the same paternal line and it's within a generation. So a brother, a nephew, a father, a son. Doesn't matter. Just pick one. It's usually whoever's most willing to do it. It's practical. Who's most interested? Who's more excited about it? Have them take it.
Great. Okay. Thank you.
Mary Lou says, I had my brother test Y37 first, then just recently upgraded to Y11 or 111. Why does the genetic distance change on previous matches? I also thought his QM3 would be further broken down, but it was not.
Yeah, so genetic, so let's say you have Y37. So that's 37 markers, right? And so you might have a genetic distance of 1 because one of those 37 markers is different. But if you're at Y111, that's 111 markers, right? So every time you add a marker, you add the probability that there's a difference. So it's common and actually expected. The higher up you go, the genetic distance will grow. So if you have someone who's a genetic distance of 1 to you at 37, it's not a surprise that there would be a genetic distance of 3 to you at Y111. That's to be expected. You have more markers. And they're just as close. Does that make sense? They're just as close because 1 of 37, 3 out of 111, it's about the same. See what I'm saying? So it really didn't, while the number changed, the signal of how close you are didn't really change that much. What was that second question? Something about?
I also thought his QM3 would be further broken down, but it was not.
No, it won't be, because remember, and I said that during this earlier in this presentation, that really you need to take a big Y test. And actually that QM3 isn't even a confirmed haplogroup. The Y111, the Y37 can't give you a haplogroup. All it can do is give you an estimated haplogroup. Granted, the estimates are really, really good, but the only way to get a confirmed haplogroup only a big Y can give you a haplogroup. The other ones are just kind of borrowing or stealing from the big Y test and saying, oh, based on big Y, we're estimating this is your haplogroup. But the STIR tests isn't where haplogroups come from. They come from Snip testing.
And QM3 is thousands of years old.
Yeah, QM3 is about 15,000 years old. But the thing about QM3 is that it's the number of testers. So you could have someone, that's the problem with QM3 is that there's so few testers out there that it takes more energy, it takes more testers to get a more refined haplogroup because, again, it's a team sport. So remember, it's not the test, it's the team. And you can have a team, if you're a Martin Serrano and you take the big Y, I guarantee you're going to get a ton of fidelity, a ton of really detailed, you can almost place your family tree on top of that big Y test. But if you're my grandfather Archuleta, who's not actually Archuleta, he's a QM3 line, it's like nothing, right? But so it's not the test, it's your team. And if you don't have a good team, you have to recruit a team.
Okay, John Coates, to everyone, he's saying, a fifth cousin and I did a big Y and formed a haplogroup with 3 variants. I tested my son, and the only change that occurred was going from 3 to 1 private variants. Why did my son and I not form our own group?
Yeah, the same reason as my dad and I didn't form our own group. It means that your son, that's me and that's my dad. Very common. Remember, it's based on that. It's like asking, you told me, Lee, that it's a 50-50 chance if I flip this coin, it'll be heads. But I flipped 4 times in a row and it's turned up heads 4 times. Am I wrong in saying that it's a 50-50 chance? No, if you keep flipping, I guarantee it'll be 50-50. So yeah, the probability, it's not uncommon for a son to have a mutation that the father did not. So let's talk about that for a minute. So I have a colleague who's also QM3, but in a different line. He has 7 sons, okay? I have 1 son and 1 grandson. So am I going to have, if I wanted this average 1 here I am saying, oh, I have a 200-year, I've said this before, I have a 200-year haplogroup, family clade. I could technically have a 53-year-old haplogroup if I wanted to. All I would need to do is have my son take the test or my grandson take the test. Boom. This average 1 would turn into a new haplogroup. I would father a haplogroup. But do I want to spend that money? Do I want to bother the tree with a line that's not established? No. Because what's the probability that my son and my grandson, if I had lots of sons or tons of grandsons, I'm like, yeah, I'm going to make this. But there's a greater probability that my line, I have 4 daughters. It's a greater probability that this average one right here will die with me or my son or my grandson. There's a chance that 100 years from now, this branch will not exist anymore, this average one. FT5172 is established. There's hundreds probably of cousins out there with this because it's a couple hundred years old, right? So again, it's not unusual. The results that he just described, exactly what I would expect. And I predicted that there's a 75% chance that you will name all of them. Look, here's an example. And there's a 25% chance that you'll name all but 1. Here's an example. And that's exactly what happened to him. If his son has sons, a ton of sons, I would say, hey, take the test. And you're going to have a family clade that is so young that it's literally, like I said, you're measuring in decades. That's how young the haplogroup is. If that makes sense.
Okay. And one more question from the chat. How do I find the earlier presentations? Sandra Evans, I will send you an email on that. If you look on YouTube, it'll be under the FACC YouTube channel, so you can look for that also. So are there any questions from the crowd here? You can just unmute yourself and talk. No questions. Okay, so it looks like you did a very good job and in time, which is great.
I'm looking at the chat there. I think there was one more question that a guy named Jeff posted.
I must have missed that one. Can you go ahead and read that?
Okay, I don't know that I understand it, but it's in the rule of 4. Why is it interesting to name private variants? Is there anything useful about having them named?
Yeah, so again, if you look at here, let me just take this out of the way.
Can you share your screen? Your
Oh,
screen shares.
Oh, I'm not sharing my screen. Here, I'll share it. Okay. So the question is there value in this over this? And my response is yes, because this is taking you, remember the big book we talked about last time? And that what we're doing is we're reverse engineering that big book. That's what we're doing. We can't get to this. You can't have this. In order to get from here to here, you have to go through here, if that makes sense. That's the whole, I mean, right? Every single one is named, right? Otherwise, you're holding here, this person here is holding 1,000 years worth of snips to himself, and science is unknown to science, and it's not going to get us anywhere. This is like off of everyone's radar. No one sees it. No one can share it. It's unique to you or the few people who are in here. In order to start collaborating, you need to name them. And that's why it's the second step. It's not the fourth step. It's the second step, right? Name those private variants.
Okay. Any more questions?
I've got one, but it may be real particular, and so I've done my test. My brother has just done his test, and I don't think it's come out of manual yet. So my block tree is not as pretty as yours as far as different colors and so forth. Mm-hmm. Now I have a deceased cousin who had taken the Y37 test. But I don't know why he doesn't show up in my block tree, and maybe this is an FTD question or
that's an easy one. So if you just take the Y stir tests, the Y111, the Y67, the Y37, you won't show up on here.
Okay.
These are only SNP tests.
Okay.
And if it was a first cousin, it doesn't really matter anyway, because your brother represents. There's no data in your first cousin that your brother isn't going to have just as well.
Yeah, actually, he's a second cousin, so.
Again, a little bit better, but if it were a fourth cousin, I'd be like, oh, find out who owns that account and upgrade it. See what I mean?
Right.
Yeah.
Okay,
like
I've got
June. Second cousins are a bit close. Second cousin.
June, unmute yourself and ask your question. Are you there, June?
I guess not.
Probably unmute her for her. There you go. She's unmuted.
Sorry, I was just trying to thank you. Excellent.
Thanks. If I've lost anybody, watch the three in order, run right after the other.
Yes.
That helps. I can tell you that it's repetition. It's just going over it again and over and over and over. You don't understand it, come back a month later, try again. You'll get it eventually. That's what I had to do.
There's no hard math, nothing like that. It's all just terminology that you have to remember.
Mm-hmm.
I've got one question for you, Lee. I've got 8 or 9 matches on my big Y. And I've looked at the matches that others have, and they have matches that I don't. Why is that?
Yeah, I have the same situation. So remember that each 37, 67, 111 has rules, right? That if you have too many differences, you fall off, right? So for example, at Y111, it's 10. You have more than a 10 genetic distance, it won't show. So that person that's a 10 genetic distance to me might be 11 genetic distance to another person that's a match, but it will show for me, but not for that person. So if you have a genetic distance of 4 at Y37, for them, they may be a 5 genetic distance to you. Well, that may break the rule as a match. And sometimes they pop in and out. There'll be a match at Y25, but not at 37. But then they pop back in at 67, but not Y111. See what I mean? They pop in and out. And the reason is that each level has a threshold number that's allowed. And if it passes that, it pops them out.
Okay.
That's why it's helpful to see other people's matches, because those are, FTNA has put constraints on you, and it's a way to kind of unbuckle yourself from FTDNA's constraints. So because that data is important to you.
Yes.
Yeah.
Now that's for stir matches.
Yeah.
These are on the big Y matches.
So they don't show up anywhere?
Not on mine, not on my screen.
So
but if I look at somebody else's, they have more matches to their big Y.
Yeah, I have a similar situation. So again, Snip tests are similar in that there's a limit to the number of mutations that it'll allow to be a match.
Okay.
So for example, I can see the names here, and I can see the names here, and here, and here, and here. I can't see the names of these two folks over here. I only know who they are because of the FTDNA projects, right? Like the Mexico project or the New Mexico Geological Society projects. I've been able to find them and get contact with them. But this person right here can see all the way down, and they can see all the way up, and they can see these folks. See what I mean? So
there's
really
a closer match.
It depends where you fit. Some of those folks are just too far away to match the rules that. And again, if you've attended some of those Facebook groups, they complain about this. They complain about about family tree DNA putting these limits and keeping you from seeing this data. And then there's an argument constantly back and forth. Well, if they increased it, then it causes problems, blah, blah, blah. Anyway, so that's why, again, I get around that. Probably the same way you get around it. You're aware of it clearly because you see other people's. So that's where the projects come in. The projects are what allows you to transcend your matches. So you can see matches all over the place that you wouldn't normally see within FTDNA itself. And quite frankly, if you're in FTDNA and you're into Big Y and you have the Big Y test, and you're not a member of at least one project, then you're not maximizing your investment. There's the New Mexico DNA project. There's the New Mexico Genealogical Society DNA project. There's the Mexico DNA project and others. There are surname projects out there. I'm in like a dozen projects, and a lot of what I know and as I put this together is because of the projects, not because of what I see in my matches.
Okay, thank you. Mm-hmm. Any more questions?
Can I piggyback on?
I have a question.
Go ahead, Mary Lou.
Okay. Just piggybacking on your question. My brother had like 9 matches when he did the 37, and now he only has 4 when he did the 111. So the other individuals that don't show up on the Y11, does that just mean they're not as closely related?
Not necessarily. It could also mean they haven't taken that high level of a test. So let me show you what I mean. Let me find it. Sorry, I have to remind myself where it actually is. Where are you? Here we go. So see this person? This person's only taken up to the 37. Right? So out of these folks, these are all matches, but only 2 of them have actually taken the Y11. They can't match you at 111 if they haven't taken the 111 test. So my question is, have all 9 taken the Y11 test? And if they haven't, then of course they're not going to match you. You don't know. And if you want to know if they match at Y111, you need to tell them, hey, it's Father's Day next month. Upgrade to the Y111 test. See what I'm saying? So that's a cool thing. Your matching list will tell you how far up they've gone. Now, if you see a Y111 here at 37, and then when you go to Y111 and this person doesn't show up, then that's interesting, and it happens. Perhaps this person is a genetic distance of 11 at Y111, and therefore they wouldn't show up for me.
That would explain it. Thank you.
Yeah. Mm-hmm.
Okay, any more questions?
Yes. I administer a kit that has 2 big Y matches, but only one of them appears in the lower levels. So what would explain having 2 big Y matches, but one of them doesn't match at Y111 or lower?
So just so I'm clear, they're a big Y match, but they're not a stir match. They don't show up anywhere in your Y stir matches.
Exactly.
Even Y12.
Exactly.
There's one way. That person may have taken a snip test. Do you know what I mean by that?
Oh, yes.
Back in the day, they're not so common now, but just a couple years ago, you could buy a snip pack or a snip, or even it was like $37 a test. You can take one snip. So then they show up on, but they didn't take the big Y, nor did they take a stir test. They just took a snip pack. Does that make sense? If not,
yes, that is funny, but yeah, it does.
So there are people out there that, again, they went the cheap route. They wanted to, the only reason to really take a snip, that's a very inefficient, costly way to do it. But in some instances, for example, if I wanted to know, if I want to spend as little money as possible to see if I matched the QL663 here, I know the QL663 is a snip that you can buy. You can buy that test for like 25 bucks. So if I just want a quick and dirty signal that I belong somewhere in this area, I could buy that for 20 some bucks. It's a lot cheaper than spending $500 some for a big Y test. And then I would have that. And if I matched positive for it, I would have a haplogroup now. But because I only took that snip test, I'm not playing in the, I'm not part of the game, right? I'm not involved in all of this. Yeah.
Yes, Douglas, I find the same thing. Not on my test, but others. They match on the big Y, but they don't have, that same person is not on any of the terminal or the STR matches. So I'm assuming that's the same thing's happening there. Okay, any other questions? Okay, it sounds like we did a pretty good job, Lee. So here again, thank you all for coming. Well, appreciate it. And this video will also be taped and put on YouTube. And remember, watch the first 2 chapters because they will explain everything else. And watch it more than once. I have to quite a bit. So thanks again. I appreciate everybody coming.